Okay, so what we're going to do is we're going to take a minute and go over the characteristics of polynomial functions. All right, so what we're going to do is we're going to define some various vocabulary terms, and after we define some various vocabulary terms, we are going to take a look at where those points are on the graph. So before we do this, I just want you to kind of take a look at this graph and let's just sort of see what's going on here. So number one, what's happening is we're starting at the left-hand side of the graph. We're going up, 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 up. So we're kind of like walking uphill until we get to this point right here. Down, after this point right here, we're going downhill. We're hitting a point right here. Then we're going up. Now notice how this line is curved, but this is sort of straight like a line. Now we're going uphill. We're hitting a point right here. We are still going uphill. At this point right here, we're actually turning and going downhill again. At this point right here, we're turning and going uphill and continuing to go uphill until we hit right here where we're going to go downhill. All right. Now, all of those points that I just kind of talked about, going uphill, downhill, we're going to name all of those points on the graph. The first one we're going to talk about is something called a turning point. So a turning point is a point on the graph or your function where it changes from increasing to decreasing or decreasing to increasing. So if you kind of want to think about this, think about it as walking uphill or downhill. So right here, okay, on this graph right here, this would be increasing because my graph is going uphill until I get to this point right here. And let's just say that this point right here is -5, 1. So let's label that for a second. So at this point right here, I'm turning and I'm actually going downhill. So I'm going to put a minus sign here just to show you that I'm going downhill. At this point right here, at -3, -1, okay, I am going to turn and I'm going to start walking uphill again. So the plus in this case is just going to mean walking uphill. Now here, I'm still walking uphill, so I haven't changed directions at this point right here. At this point right here, at 1, it's not quite 4, so let's just say 1, 3.5. We're not going to be quite exact. Okay, at that point right here, I'm actually turning, and now I'm going downhill. All right, at this point right here, let's just say this is 1, 2, 3, we're just going to say 2.5. It's not exact. Okay, at that point right here, I'm turning, and now I'm starting to go uphill again. Okay, at this point right here, I'm still walking uphill. At this point right here, I've now turned direction and I've started to go downhill again. So that's all that those minuses mean. Okay, so this is 6, 1, 2, 3, 4, 5.5. Okay, I know these are not exact, but we're just going to kind of do the best that we can with what we have right here. Okay, so a turning point is where it's going to change from increasing to decreasing. Now notice how you have the word point here. So that means here you have to include an X and a Y value. All right, so my turning points, notice how I went from going uphill to downhill. So -5, 1 is going to be a turning point. Okay, because I changed from going uphill to downhill. Here I was going downhill. Okay, now notice I changed from going downhill to uphill at -3, -1. Okay, so that is also a turning point, the -3, -1, because I turned and I went from downhill back to uphill. This is not a turning point because notice I'm going uphill and I'm going uphill again. This is going to be a turning point right here because I was going uphill, I'm turning, and I started to go downhill again. Okay, so 1, 3.5 is also going to be a turning point. Okay, and then right here, my graph is increasing. So I know you're kind of, hard to walk up a hill that looks like this, but you could be walking uphill. This is a turning point right here because I'm walking uphill. All right, and that is 3, 2.5. And then the final point right here, notice I'm going uphill, and at 6, 5.5, I start going downhill again. All right, so that point right there, the 6, 5.5 is also a turning point. So once again, I just want you to keep in mind that these are points. They are X, Y points. They're called turning points. Now, local extrema. So local extrema is going to be something called the collection of all the local relative mins and maxes. All right, now if you take a look at this graph right here, this graph is going to go down forever here and down forever here, okay? However, it does have what we call local mins and local maxes. So what that means is they are higher than all the other points around it. So basically what you're looking for here is you're basically kind of looking for the top of a hill and you're kind of looking for the bottom of a hill, okay? All right, so if you notice this -5, 1, this point, this 1 is higher than all of these points around it. Now, since we're talking about how high and how low, that's our y-axis. So notice these are y values only. Okay, so for this one, all right, your local extrema is y equals 1. Okay, and I'm going to label it y equals just so you remember it's just your y values. Now, if you take a look at this point right here, okay, this is kind of like at the bottom of a hill. This -1, this y value, is lower than all of the other points around it, okay? So that is -1, okay? Now this point right here, it's not really higher or lower than any of the other points around it. It's just kind of like part of your graph, okay? Like I said, think of a top of a hill, bottom of a hill. Now right here, this 3.5, okay, looking at the y values because how high it is higher than all the other points around it. So it's kind of like at the top of a hill. Okay, so 3.5 is also going to be 1. All right, now take a look at this 2.5. This is like at the bottom of a hill. It's lower than all the points around it. So 2.5 is going to be 1. And then we have our last one right here. So this is at the top of my hill. Okay, this 5.5 is higher than all those other y values around it. So it's also going to be considered a local extrema. Okay, and notice they're all y values here. Okay, now we're going to take a look at something called the local min, relative max. All right, now these were all the local extrema, so all the highs and all the lows. So basically what we're going to do here is we are going to break these down into which are my local mins and which are my local maxes. And I'm actually going to kind of do this over here just so there's a little bit more space. Okay, so local maxes are going to be points that are higher than all the points around them. So this one, sort of think of the top of the hill. Local minimums are lower than all the points around it. For this one, sort of think of the bottom of the hill. And you're going to use y values only, okay? And the reason it's y values only is because y is your how high and it's your how low. Okay. All right. So let's take a look at all these points that we had. So we have our max and we have our mins, and these are our local. They're local means they're not the highest the graph can go or the lowest the graph can go. They're just the top of the hill of all the points around it, bottom of the hill of all the points around it. So let's go to this one right here. This is a local max, okay, because it is higher or at the top of a hill. This -1 is a local minimum because it's at like the bottom of the hill. This was not a local min or max, okay? This one right here, this 3.5, that's a local max. It's higher than all the points around it. It's at the top of the hill, okay? This 2.5 is at the bottom of your hill, so that's a local minimum, okay? It's not the lowest the graph can go, but it's lower than all those other points around it. Okay, this right here, this 5.5, this is also a maximum because it's at the top of a hill and it's higher than all the points around it. Okay, so let's take a look at 3 new vocabulary terms. All right, so our next one is going to be called the global min or absolute min, the global max or the absolute max. So that is looking at your graph and saying, what is the absolute lowest the graph can go? The graph is not going to go any lower than this particular point. The global max is the highest the graph is ever going to go. It's not going to go any higher than this particular point. Notice they're also in terms of your y value, okay, because think about how high, how low is always going to be our y-axis. Now, we've already talked about all these points being our local mins and local maxes, okay? Which of those are the highest that the graph possibly goes and which are the lowest? Okay, so for the global min, so I'm just going to put G here for global minimum, okay? Now, notice how this graph goes down forever and ever and ever. This graph does not have a lowest point, okay, because it's going down forever to infinity. So there is actually no global minimum. Okay, how about a global maximum? Is there a point that you see here that is the highest the graph goes? Well, if thinking of a roller coaster, this point right here is going to be the highest that this roller coaster goes. It goes down forever on this side, so it's not going to go any higher than this. So the global max is actually 5.5. Okay, and that, remember, that's always in your y values, okay, because you're talking about how high and how low a graph is going to go. Okay. All right, now increasing interval. So this is once again sort of thinking about your increasing intervals are going to be where you're climbing uphill. Decreasing intervals are going to be where you're climbing downhill. All right, and for increasing and decreasing intervals, basically what you're going to do is these are your x values only. Okay, and you're going to say, like, where are my x values, where are my y values getting bigger for increasing, where are the y values getting smaller for increasing or decreasing. So increasing, I just think walking uphill. Decreasing, I think walking downhill. And you're also going to use parentheses here. And the reason you're using parentheses is because at the turning points, I want you to think of at the turning points is going to be where you're changing from increasing to decreasing. And you're using parentheses because at the turning point, you're neither increasing or decreasing. You're kind of thinking of it as like a stop sign. Okay. All right. And so you're increasing, you're sort of thinking it as like, where am I starting to increase to where am I starting to decrease? So let's just go ahead and put our pluses to where we're increasing. So we're walking uphill here. We're walking downhill here. We're still walking uphill, still walking uphill. We're going downhill here. We're walking, oops, sorry, wrote that wrong. Okay, downhill. We're walking uphill. And then once we hit here, we're walking downhill. All right, so I'm actually going to write my increasing intervals over here just for space. Okay, so your increasing intervals, notice going from left to right, I am going to be, I'm going from negative infinity. Okay, so I started increasing or walking uphill from negative infinity. Okay, and where did I stop? I stopped increasing at -5 because here I started going downhill again. So I'm increasing from negative infinity to -5. You're always going to put your union symbol. I was going downhill here. All right, so let's include our decreasing. Okay, so I'm decreasing from -5 to -3. This is where I stopped going downhill. So this is why you're going to use parentheses, okay, because at these points right here, I'm neither increasing nor decreasing. And remember, brackets mean include the number. I'm just sort of stopped there, okay? So now starting at x is -3, I'm going to start going up again. Okay, so that's an increasing interval. So -3, I'm increasing here. I'm increasing all the way until I hit x equals +1. Okay, now at +1, I turned and I went downhill. Okay, so I went from +1 to +3, where I'm actually decreasing. Okay, and then at +3, notice I started increasing until I got to +6. Okay, so I'm going to go from +3 to +6 is the x values where I was walking uphill. Okay, and then notice at 6, I started going down or decreasing forever. So from 6 to positive infinity, okay, my graph is actually going to be decreasing or going downhill. All right, we will be going over this, so if you have any questions, please let me know.